Good morning.
Good morning.
Good morning.
So, Winslow, you're out of focus a little bit. I don't know if it's one of those deals where you need to have it reset. All right. Well, let's see who's here today. All right, Rex.
That whole carrot.
Alana.
Here.
Tiana.
Here.
Taylor.
Here.
Auburn.
Here.
Pretty.
Cameron.
Here.
Andrew.
Here.
Shandon.
Here.
Junior.
Here.
Caden.
Here.
Jordan.
Here.
Ellie.
Here.
Dominic.
Here.
Brooke.
Here.
All righty. Okay, so today we are going to finish 8.1 and maybe go into 8.2. I'm not sure. So we've just got a little bit to do on the, I think on the first side. And most of our work today is going to be on the law of cosines. All right. So I don't know. I don't know if we're going to get to 8.2, but I went ahead and did the guided notes just in case we get to it at the very end. But I'm not sure. We'll just have to wait and see how things go. But does anyone have any questions before we get started today? Okay, so let's see. So Miss Lopez, is Miss Lopez there in Winslow?
Yes, I am.
Okay, so the way that the camera is there it is. Oh, you fixed it. Perfect. I thought it was going to be on our end. I was just sometimes that's the one where they reboot between classes. And so I was just going to say before your next talent class, but you got it perfect. So disregard what I was thinking. Okay. So thank you. All right. Well, let's go ahead and get that last little bit about this still on the law of sines. Okay. We were talking about how many triangles would be possible in different situations. And so if the angle is acute and the height is less than both sides, then there are going to be two possible solutions. Okay? So H is less than A, which is less than B. Right? Now, if A is obtuse, then you can't have two triangles. Okay? So it has to be acute. So let's say we wanted to, let's just go to the visual of what's going on. See, if you are given an angle, and then a side, and then another side, then see the third side could go out this way, or it could come back this way. So this third side A, could go either way. And so that's why it's possible that if you're just given the angle, side, and a third side, you could have two possible triangles because A could swing either way. Okay. So this one says draw. So in your thing, it just says draw two triangles for which A is 58 degrees, side A is 4.5, and B is 5. So I want you to just, we're just guessing. Right? We're not using a protractor or anything to get the angle exact. So I just want you to approximate two triangles that would make this work. Okay? Okay? So let's see, did I draw the, oh, I remember that. These are lousy drawings. Okay. Matter of fact, let's just redo this. Okay. So if you're trying to approximate an angle of 58 degrees, okay? So if you have, here's your base, and then, it's going to be a little bit more than 45, so maybe like there, okay? All right. So, and we're going to say that that angle is approximately 58 degrees. Okay, and that's angle A. And then we're going to have angle, or side B is 5. Okay? So if this is angle B, then side B would be 5. All right? Now, we really don't know anything here about this third side, how long it could be. All right? So when you're drawing your triangles, see, to draw two triangles, then see this third side that's at a given length could come down like this, or it could come down like this. And so we get the two separate triangles that way, because you don't really know which way it goes. Okay? And you don't know anything about this side AB, or side C. Okay? All right, so any questions on that? We're just estimating here, so it's not like your triangles have to be perfect. But it's just, you need to know that that third side could swing in or it could swing out. And still the angle is not going to change. This distance is not going to change. And then these two distances, 4.5, would be the same either way, whether it's coming out or if it's coming in. Okay? All right. So any questions on that front side of that paper, for A1? Okay, well, let's go on to the next part. All right, the next part is on the law of cosines. So the law of cosines is another, I know you've had the law of cosines. It's not quite as easy to use as the law of sines. The law of sines, you just set up a proportion and cross multiply. The law of cosines is a little bit trickier. All right. Now, so with the law of cosines, there's actually three different ways that you could write it down. but it's just a permutation of the letters. So I actually just memorized this third one. So if you want to just write down this one, but just know that the A's, the B's, and the C's actually could go anywhere. But, so like here, if C squared equals A squared plus B squared minus 2AB cosine C, these two letters are the same as these. And then the angle is the same as the side that's by itself over here. So see, if you have the B by itself, it's cosine B. If you have the A by itself, it's cosine A. So whatever side is by itself over here, that's the cosine of that opposite angle. Okay? So that's why I only memorize this one, and then I just, use whatever side that I need. All right. Now, so what happens if your angle is 90 degrees? Well, the cosine of 90 degrees is 0. And so this whole term would go away. And so if we have, if our angle is 90 degrees, then the law of cosines just becomes the Pythagorean theorem. So it's kind of like, if you think of the law of cosines is an extension of the Pythagorean theorem. It's a way to find the sides of the triangles even when you don't have a right angle. Okay? All right? Okay, let's see. Law of cosines. Now, the other thing that I want to point out and make sure that you have in your formula is that it's the minus. It's that it's minus 2 times the angle times the 2 times the sides times the cosine of the opposite angle. So the other sign here is a plus, but make sure that you have a minus there in your formula. Okay, however you have it written down. Okay, now so when we have all 3 sides and you don't know any of the angles, then what our plan of attack is going to be is first we'll use the law of cosines to find the first angle. Then we'll use the law of sines to find the second angle. And then we'll subtract those 2 angles from 180 to get the third angle. So I'm just trying to give you the big picture here as to what it is that we're going to do. Now, so when given all 3 sides of a triangle and asked to find all 3 angles, you should first find the angle opposite the longest side. Now, that's extremely important because you can actually run into issues where you could actually make a mistake if you find the smallest side first. Okay? So you want to find the angle opposite the longest side. All right? And then to do that, we're going to use the law of cosines. Okay, so this says find the 3 angles of this triangle. All right, so this is kind of typical of a problem that we have to do, or it might say solve the triangle. So remember solving the triangle means find the unknown stuff, the unknown sides, the unknown angles. So here we're trying to find the unknown, we're trying to find all 3 angles. So which angle are we going to find first?
The one opposite the longest side.
Yes, so that would be angle B. All right, so then what we're going to do is use this version of the law of cosines. So if we're going to try to find angle B, then it's cosine B goes over here, and then we have B by itself over here. Okay, So we're going to use b squared equals a squared plus c squared minus 2ac cosine b, because it's angle B that we're looking for. Okay? All right, so now as we plug in, okay, so so we have 19 squared equals 8 squared plus 14 squared minus 2 times those same lengths again, 8 and 14, times the cosine of B. So this is the angle that we're trying to solve for. All right, next, we just do some algebra here. So square stuff out. So we get 361 equals 64 plus 196 minus 2 times 8 times 14 is 224 cosine B. All right, add 64 and 196 and get 360. All right, now this is the step where most of the mistakes are made, okay? What do you think would be the most common mistake in this step right here?
Subtracting 224 from 260.
Yes, and why do you not do that?
Because the 224 is the coefficient of cosine B.
Excellent, excellent. Do y'all understand what he's saying there? Okay, great job. So what you do, instead of subtracting these, you subtract the 260 from each side. Okay? Because the negative 224 is the coefficient of cosine. And multiplication has higher priority than subtraction. All right, so now to get rid of the negative 224, you're going to divide. Okay? Now, when you're writing it on your paper, you can, leave it to write it. You can round it to 3 decimal places. But if you have it in your calculator, just leave all the decimal places there. Okay, and so then you just to solve for angle B, you're going to do inverse cosine of this. Okay, now the inverse cosine is going to give you the angle in whatever mode that you're in. So if you want the answer in degrees, make sure you're in degree mode. Then you'll do the inverse cosine, and so then you'll get 116.801. But do you see how if you didn't put it in degree mode, then it's going to give your answer in radians. So you got to make sure you're in degree mode. So 116.801. So then that's your first angle. All right, any questions on that? Okay, so we use the law of cosines to get the first angle. To get the second angle, we're going to use the law of sines because now we have an angle side pair. We have angle B and we have side B. So we have an angle side pair, so we can use the law of sines. The law of sines is usually a little bit easier. And so that's what we're going to do next. Okay? So now I'm going to go after the next largest angle. So C. So I'm going to use the law of sines to find C. So I have my angle side pair. So I have B over the sine of B. So 19 over the sine of 116.801 is equal to 14 over the sine of C. And so now I'm going to use this proportion like we did on Tuesday to find angle C. So I'm going to cross multiply. So 19 times the sine of C is equal to 14 times the sine of 116.801. Divide each side by 19. And so then what I do, I put all this in the calculator and do the inverse sine. So it's the inverse sine of all of that. And so I can put that in there in one step. The inverse sine of all of that. And so I get 41.124 degrees. Finally, to find the third angle, I subtract from 180. So I take the two angles that I found, subtract from 180, and then I get the third angle, which is 22.075. So they get progressively easier. So you do the law of cosines first, then the law of sines, and then subtract from 180. All right. Anybody have any questions before I have you do one? All right. So go ahead and try practice 2A. So you're going to find all three angles. Anybody need me to go back to the law of cosines part? To where you start?
Can you go back?
Yeah. Okay, so this is where you start finding the biggest angle. So using the law of cosines. So that's what you need to do on practice 2A is figure out which angle's the biggest and then go after that one.
So like for the largest angle, you would always use the cosine?
Yeah, for the law of cosines, you're going to use that first. Okay? So like in practice 2A, which angle are you going to go after first?
12.
C.
C. So the one that'll be by itself here will be side C. So it'll be C squared equals A squared plus B squared minus 2AB cosine C. Does that make sense? So you're going after angle C.
I have a question.
Sure.
From the practice problem we just did, how did you go from 101 equals negative 224 cosine B to negative 451 equals cosine B?
I divided each side by negative 224.
Okay, thank you.
So actually, see what I did is I didn't. Now I wrote it on the paper like this, but let me just kind of show you a little calculator trick at that point. Just to get more accurate, you can actually here. Here we go. Okay, so when you're at that point, so you do 101 divided by 224, negative 224. Okay? All right. So see, I rounded here to write negative 0.451, but now that's equal to cosine B. So what I can do is do the inverse cosine, so second cosine of the last answer. And that way I don't have to retype it, and it's actually more accurate. So I do second cosine of the last answer. And so then I'll actually get, oh, I remember I've got to put it in degree mode. Okay, or I could actually just include the division of 101 divided by negative 224. That way. So that way, I mean, usually it's not going to make a big difference. But if you have to be really precise with your angles, then that's a little trick to make them more accurate, is you try to not round. Okay. All right, so Dominic, what is the first angle? Let's see, we said angle C. So what's the measure of angle C?
117.2796.
Excellent. Okay. All right, next. Oh, any questions on that? All right, so Andrew, let's see, what's the next biggest one? That would be angle B. So what's the measure of angle B?
34.20.
Okay, now let's see. So 34, see, that's off by 2 degrees. So probably either I rounded a little too early or you did, because really we should be more accurate than that. So, so let's see if let's go through that one here. So did you get 117.280 for the first angle, Andrew?
Yes.
Yes? Okay, sorry, you guys froze up there for a second. Okay. All right, so then if you say the sine of that over 12 equals the sine of b over 8, and then you cross multiply, so you have 8 times the sine of 117.280 equals 12 sine b. Divide each side by 12, and then do the inverse sine of all of that. Okay, so let's, oops. Okay, so, all right. Whoa. All right, so Andrew, why don't you kind of put it in the calculator again with me and just make sure. So if we do the inverse sine of 8 times the sine of 117.280 divided by 12, close off the sign there, and so 36.335, so I would say 0.3, so rounding up 0.336. Okay, so this one's just rounded too much. So 0.336. Let's change that. 0.336. Okay. All right, so normally I do want you to carry out your computations to 3 decimals. So here, it looks like mine was probably rounded too much. So yours may have been more accurate than mine. All right, so any questions on that, or keying it into the calculator or anything like that? Okay, I mean, depending on where we round, I mean, it could be a little bit different, but like, let's say on a quiz or a test, I'm not going to have the angles so close together that like a rounding thing would cause you to miss a question. I'm not going to do that. Okay. All right, so then let's go to the third angle then. All right, so Ellie, what would be the third angle?
26.384.
26.384 degrees. So I don't know why I've got that, but okay. All right, good job. Any questions on that?
Could you explain to me where you got the 12 from in the second step for the sine?
Okay.
Like this angle B.
Okay. So this 12 in the law of sines?
No, like the second step on the other side of the equal sign where it says 12 sine B.
Oh, okay. So if we're looking for side C first, okay, then the side that's by itself is the one that's opposite the angle we're looking for. Okay, so that's why we have the 12 by itself here. Is that your question? Why do we have the 12 here?
Like in the equation. In the
So-
equation you were doing
So,
for the second part, the sine part.
okay. So in the law of sines, then this 12 is what you're
Go
asking about?
down. Go down one and to the right.
Okay.
To the-
Okay. So here, so in this step, we're cross multiplying. So we have 8 times the sine of 117 equals 12 times the sine of b. So we're cross multiplying. All right. Now we're trying to solve for the sine of b. So you divide each side by 12. Okay. And so then we get this over here, and all of that is equal to the sine of b. So then if you do the inverse sine of all of that, you get angle b.
Okay, yeah, I got it. Thank you.
All right, good. Okay. Okay, so let's see. Oh, I already answered that blank. What familiar formula do you get from the law of cosines if the given angle is 90 degrees?
Pythagorean theorem.
Pythagorean theorem. Okay. All right. So now let's look at another. We're still working with the law of cosines. But in this example, we're trying to solve the triangle. And instead of knowing all three sides, side, 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 here we have side, angle, side. Okay. Now, the way to remember that you're still going to use the law of cosines here is that you don't have an angle side pair. See, to use the law of sines, you must have an angle side pair. There's no angle side pair. Okay? So, what we're going to do here, when you have side, angle, side, what we're going to do is use the law of cosines to find side A, the missing side. Okay, so the law of cosines. So the missing side, that's in the law of cosines, that's the one that's going to be by itself in the formula. So since we're going to find A, then A is the one by itself over here. And then see, when we do cosine A, we're going to be able to plug in a number here. As a matter of fact, all of this right side we know. And so we're finding side A, so that's the side that's by itself over here. All right, so now when we plug in, we get A squared is equal to, and so the two sides, 10 and 15, go here, 10 squared plus 15 squared, minus 2 times 10 times 15, and then the cosine of the angle that we know. Now, to solve that, see, all that is A squared. So, to solve it for A, we can just take the square root of all of that. Now, the beauty in these problems is that you can just punch it in your calculator and do it in one step. Okay? So then you just punch in your calculator the square root of, and then open parentheses, 10 squared plus 15 squared minus, and you can do some of the math in your head if you want, but you could just punch it all in there. Minus 2 times 10 times 15 times cosine of 115, assuming you're in degree mode, and you just press enter, and that's your answer. Okay? So your calculator can just do it all in one step, and that's really nice. There's no manipulation or anything. Okay? All right, so go ahead and try practice 2B. Oh, I actually didn't finish this problem. So hold on just a second. So here, that's side A, and now we have an angle side pair, so we can use the law of sines to find this angle. Okay? Just like we did before. So now to find angle B, we use the law of sines because we have the angle side pair, sine of 115, and we have angle side A. And so we cross multiply. And then once we get angle B, then we subtract from 180 to find angle C. So it goes law of cosines, law of sines, subtract from 180. All right? Okay, so now try practice 2B. All right, so Tiana, what's tell us side A when you get it.
I got 18.257.
Oh, me too.
Very good. Any questions on that? Okay. All right, next, angle B. Brooke, when you've got that one.
59.662 degrees.
Okay, 59.66255. That's close enough. Okay. And then the third angle I got is 40.345. Subtracting from 180. They found C first, but and I guess once you have the biggest angle, it doesn't matter. But normally, I am in a habit of finding the biggest angle and then the next biggest angle and then the smallest angle last. That's just kind of how I was taught. Okay. So, but once you find 2, you subtract from 180 to get the third one. All right. Any questions on any of that? Any of that you'd like me to go over? Again, law of cosines, law of sines. Okay. Okay, so when solving for an angle, if you're given side, 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 then you're going to use the law of cosines. Okay. Um, I'm not sure what this is trying to say. So if you're given all 3 sides, why would you solve for a side? So let's just cross through that one. I'm not sure what that even, what I'm trying to get at there. But when you have all 3 sides and you want an angle, use the law of cosines. Okay? All right. Let's just go ahead and jump to the practice problem. Okay, so it says in a softball game, a batter hits the ball 240 feet to dead center field. The center fielder then throws the ball to third base and gets the runner out, who is trying to move over from second base. The distance between the bases is 60 feet. How far did the center fielder throw the ball? All right, now, so the first thing I would recommend you do here is draw a triangle. Okay, so see if you can draw the triangle that you would need to solve in this problem. Okay, so let's just start there. So just draw the triangle. Let's see, where's my triangle? Okay. Well, all right. I don't know why I didn't draw the triangle here, but let's do it. Okay, so the ball goes from home plate. So let's say if this is home plate, and then it goes to center field. All right. Then the center fielder is throwing the ball to third base. Okay. So that's your triangle. Now, what we're wanting to know is how far the center fielder throws the ball. Now, the distance between the bases is 60 feet. So that's 60 feet. Let's see. 240 feet is how far the ball went. Okay. Now, how do we get this angle here of 45 degrees? How do we know that that angle is 45 degrees?
It's in the shape of so the field's in the shape of a diamond.
Right. And actually a square, in that all of the angles from each base is a 90-degree angle. Okay, and so then half of it, so if this is 90, the angle going from first to third, if that's 90, then dead center field right over the pitcher's mound here, that's going to be 45 degrees. Okay, so then if we're looking for this distance here, how far the center fielder threw to third base, then that's our distance C in this problem. Okay, so I kind of messed it up because I didn't have the picture drawn. So now you kind of see the whole problem. But so you have, C squared equals A squared plus B squared. So 60 squared plus 240 squared minus 2 times 60 times 240 times the cosine of 45. And that's the one, those are the ones that you can just do it in one step on the calculator. Okay. So the key, I think, is to be able to draw the triangle. So any questions on that? All right. Well, the last little bit here of this section is dealing with areas of a triangle. Okay. Now, way back in junior high, or maybe even sooner, you learned this is the kind of the standard form for the area of a triangle: 1/2 base times the height. Okay. And really, that's what you use most of your years coming up. Okay. All right. Then, based on the law of sines, there's another way that there's another formula, and it's 1/2 AB sine C. Now, again, there's different ways that you'll see this written, but it's just 1/2 of two sides, the product of two sides times the sine of the included angle, the angle in half in front. Okay. So, or it's 1/2 the product of the lengths of two sides times the sine of the included angle. So kind of how I remember it is 1/2 AB sine C. So that's the area of a triangle. Okay. So if we were going to find the area and we're given two sides, A and B, and the sine of the included angle, just go ahead and put that in your calculator and see if you can get the answer for me, the area of that triangle. All right, so Rex, when you've got it.
I got 212.718.
212.718. Perfect. Now, the units for area are always squared. So, and since the sides are in inches, then it's square inches are the units for the area. Okay? All right, anyone have a problem getting 212? All right, so that's when you know one of the sides, like side angle side. All right, now the last formula is what's called Heron's formula, and it's to find the area when you have all the sides and no angles. So side, 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 no angles. And that formula is the square root of S times S minus each side, A, B, and C, where S is what we call the semi-perimeter. Now, I know you know the perimeter of a triangle is the distance around, or the sum of the sides. The semi-perimeter is where you find the perimeter and then divide by 2, or multiply by half. So it's half the perimeter. So you calculate the semi-perimeter, and then it's the square root of S times S minus each side. Okay? So see if you can do practice 3B by first calculating S and then plugging it into the formula. Now, if we drop off before we go over the answer, we'll start with that on Monday. So, what would be the semi-perimeter for this?
11.
Yes. So add them up is 22, divided by 2 is 11. So then you put in your calculator the square root of 11 times 11 minus 5